Okay. So hello everyone. We're going to start now, although there's some people still coming in. My name is Adeyemi, or Ade, and I'm originally from Spain. I'm here for Workday. I'm the Vice President of Technology Strategy at Workday, and I work with Vlad, who is our Director of Engineering, focused on data and analytic products. We both came to Workday over a year ago. We were acquired after we started our company called Identified, from which I was CEO and he was CTO. I'll talk more about Identified later. But essentially, we wanted to build a LinkedIn on top of the rest of the web, particularly Facebook, and use social profiles to make recommendations to companies, particularly in who should be their next hire. So more on that later. But after that, we got acquired by Workday, and the big idea was, what could we do if we mix that kind of technology and public data with the data that was inside Workday? What kind of recommendations we could do for companies? For those of you who don't know much about Workday, it's essentially an HR and financial software transaction system and database in the cloud. So big competitor of Oracle, but cloud-based. And we mostly work with large Fortune 500 companies. And the title of our talk today is Smartest Decisions Through Data. We just generally have two convictions. One is that companies ideally want to make better decisions and not worse decisions. And two is that data can help with that. So with that, I'm going to start. So evolution of analytics. There is a lot of, obviously talk and frameworks about how analytics is classified. This is probably one of the most typical ones, going from operational reporting, which is essentially dashboards, to prescriptive analytics, which is how we call recommendations. And basically, when we talk about Workday analytics and the inside applications that we're going to talk about today, we are only talking about level 5. We're only talking about a system that will recommend you what to do at any given time for decisions in the day-to-day life of how you are running your business. Our inspiration for this is really the consumer web. We're like, well, in the same way that like Pandora recommends you a song or like Netflix recommends you a movie, shouldn't your HR system tell you when you should be having a conversation with an employee because they're about to quit? And shouldn't you just get a notification on your mobile? So that is what we're aiming at. We're not really here to talk about dashboards or about reporting. And so we talk a lot about, yes, recommendations that are going to tell you what to do, but sometimes that comes across the wrong way. So when we originally started talking about this retention risk application that we'll talk about later, articles like this came out. Like, right, big data knows when you are going to quit your job before you do. And it's a little bit threatening. It's not like ideal, right? It sounds a little bit big brother. And that is not really what we're going for, because we always say that the system recommendation is only as good as the data that you put in. And you can't really put the entire world data into a system. So there are always going to be things that are on the manager's brain. And whenever we're selling these products to clients, we always say that the data, the output of the model should really be the beginning of a conversation. And that the best decisions come when you mix objective data results with whatever is on people's brain. Okay, so why aren't all companies taking decisions like this? Why aren't all companies run in analytic applications that tell them when to raise the price, what customer they should sell to? So basically, it's because it's really hard and expensive to actually build a prescriptive analytics system. This is our framework of all the things that you need to do, from like data aggregation, classification, choosing the right algorithms, wrapping and creating the application, and then putting in the machine learning loop. But as we'll know, on top of that, there are tons of things, from like, data mining to like prepping that take a lot of time and a lot of expertise. And what we are seeing in a lot of our clients that actually have great data science teams, such as oil companies, for example, that do really complicated models in like thinking where they're going to drill for their next oil field. They're best people when it comes to data. They're actually focused on things related to their business. They're not focused on their HR problems or on the financial problems because it's not their core. So what we want to do at Workday is basically wrap all this in an application that you can use as a business user. And our aim with that is that you actually don't really need to know even what a regression is in order to get something out of the application. You just need to be able to ask a question. So now let's talk a little bit about those questions. So the first one that we have actually gone to market with is the top performer retention. And I'll just go to a concrete example, but for example, one of our clients, the original one with which we tested this, was a large medical manufacturing company. And they gave us 25 years of historical data. And they were like, well, could you figure out which of my top performers are going to quit the company in the next 12 months? And after a few weeks, we came back and we said like, hey, we actually think you have 170 people that are about to quit. And this is going to cost you about $20 million. So you should probably pay attention to it. And obviously the next question was, okay, what can I do? And what was interesting is that we didn't have any expertise in medical manufacturing. So we didn't go in with any prescribed notion of what are the factors that go into retention risk for medical manufacturing engineers. It was a pure machine learning model, and we told them, give us as much data as you have about, I don't know, promotions, pay benchmark, employee satisfaction data, surveys about how good the coffee is in your company, tweets, anything. It's like put it into the model, and we'll see what comes out. No bias. And it was really interesting, particularly because some of the factors were, kind of like expected, like, promotion rate. If you don't promote someone in 2 years, they're more likely to quit. But it turned out that for top performers, the actually number one most predictive factor was number of career functions that the person had taken. And what I mean with that is how many different departments they had worked at. And this was something that only worked for top performers. So if a top performer have moved from engineering to sales and then to marketing, they actually had a 30% more likelihood of staying at the company than someone that had just been in one job function. And this was consistently true across the board, but yes, for top performers. And then we actually started looking at which moves were good ones and which moves were bad ones. And oftentimes, the most popular moves were actually the ones that will decrease performance and increase retention risk. But when we go to another company, the model might put in a completely different answer. And if you slice it for different job functions, again, it will give a different answer, and the model is continuously learning. So it could change from month to month, depending on what is happening on the stock market. And the thing is that for those insights, you actually basically just have to install Word and plug it on. So there is no data prepping, there is no feature selection, you just put everything that is on your system, and yes, the model starts spitting out answers. So it's one example, we have others, but this is one example of what we're focused on. The key to being able to do this at a scale is actually data classification technology, and this data classification technology that we had developed at our startup. Originally, it was to classify job titles that people will put in social media. So the example you're looking at is job titles for nurses. I didn't know this a few years ago, but there are actually 10,000 ways in American English that are correct to say, I am a registered nurse. That was really painful to find out because we did manually originally. It took 3 months. And if you plug that in a business plan, to do that for every industry is going to take you about 10 years, so it wasn't very efficient. So we ended up building a series of algorithms to do this at a scale that Vlad will talk about later. It's also very good at figuring out what part of the information is noise. As an anecdote, turns out that the number one most common university that people put on Facebook is Howard's School of Wizards. and probably you shouldn't make a lot of decisions based on whether someone graduated on the dark arts. But this is part of the magic that actually allows you to just take data and make sense of it automatically. Other thing I wanted to comment on, this is actually a representation of how for that particular client we were classifying people in our application on a performance by retention risk axis. So you have performance on the X and retention risk on the Y. And if you look at your left, you will see that in the first diagram, actually as performance increases, retention risk decreases. And that is a healthy company. So this was true for the general company, and it was true for 23 out of 24 departments. And we very quickly realized that there was one department where the curve was inverse, as you see on the right. So as performance increases, retention risk increases. And it was interesting when we showed this to the company, we're like, hey, what do you think of this? And they immediately were like, oh, of course, yeah, that's the Terminator manager. And again, it was like, oh, well, now actually you have data to prove that there is something weird going on here. Finally, before I was talking about how the output of the model should be the beginning of a conversation, and that best things happen when you had manager input together with model input. So in another client, we actually ask managers for a particular quarter, for a particular department, to predict how many people they thought were going to quit the company. And they said, as you can see here, about 300. And then our model said, well, it's going to be around 650. And what ended up happening is that about 850 quit the company. And the model predicted about 600 of those. The manager predicted about 250 of those. But together, within the model and the manager, they will have predicted everyone. And that's why we always position these applications as this really should be the beginning of a conversation, and as much you put into the model, as much you're going to get out of it. We're seeing around 20x increase in what will be the benchmark with a random prediction. So far we're very happy with the model's performances. And finally, before I pass it to Vlad, I just wanted to say that this is just one example of the kind of applications we're building. We basically equate an application with a business question. So retention risk is who's going to quit my companies. We're building others such as who should be my next hire, which of my clients are going to stop paying me, who should be my next client, and so on and so forth. And with that, Vlad is going to talk a little bit about what is actually the technical stack that goes under the hood of these applications.
Thanks, Ade. So just a reminder, I'm Vlad Giverts, Senior Director of Software Engineering at Workday, and I'm heading up the machine learning teams, the engineering teams that are actually building these applications that we're calling insight applications. So I'm going to talk specifically about the retention risk application, and, well, more importantly, all the technology that goes into it. But really, this is the same kind of technology that's going into all of the applications that we're building that Ade was talking about. So, without further ado, this is the tech stack. There's a lot more little details that we're not talking about, but this right here are the high-level points. You see we have a machine learning pipeline built on top of Spark. We use Kafka to stream data from the application. We have Elasticsearch for retrieving the data. And then we use Yarn to manage distributed computing and HDFS for the storage. Let's zoom in a little bit. Let's first talk very briefly about what we're using search for and how we're doing it. So basic flow is we have this transactional application, Workday HCM, Human Capital Management, Workday Financials. People are using these applications all day long. They're constantly getting updated. And as these updates are occurring, these transactions, we stream those changes via Kafka into our indexing service. And this indexing service picks up those changes and stores them in Elasticsearch. And now we can effectively search across any important data in the whole application very quickly and easily and in near real time. This is a very quick process. And the reason I'm mentioning this is actually quite important to the machine learning architecture as well, and we'll get to that towards the end. So if we go back to our big picture view, let's now talk about what we're doing with machine learning. So our ML pipeline, how does it work? What is the guts of it? So first of all, I mentioned it is based on Spark, so it's naturally distributed by nature. Because Spark is kind of horizontally distributed across as many nodes as you want, and it's in memory, so it means it's very, very fast. But if we, and the way it works today is initially, particularly whenever a new customer starts running with retention risk, we'll go ahead and take a snapshot of all the data in that customer. We'll run it through the machine learning pipeline, and we'll push out the results into Elasticsearch for easy access. However, let's zoom in a little bit. What's happening in this ML pipeline? So I mentioned already we're snapshotting the data, and then what? Well, then we do something known as feature extraction. So what does that mean? This is actually where the bulk of the work is. A lot of when data scientists are trying different things, what they're actually doing is trying different features and different combinations of features. So let's talk about that. There's something, there's raw data that we can get, and I'll talk about what the raw data looks like in the future, but in a moment. But what are features? Features are something when you take the raw data and you translate it to a number. It's usually something like 0 to 1, or sometimes it could be 0 to infinity. That can then be passed on to a machine learning algorithm to figure out, well, which of these features are predictive. So I'll give you some examples. Up here you see one feature called tenure. That one's very easy to compute. Tenure is just, for every worker, find the date that they started and the current date, and you just subtract whatever the current date minus the start date, and delta is how long they've been at the company. Terrific, nice and simple. Promotions, pretty simple too. We look over all the transactions for every worker, count up how many times they've been promoted, and that's number of promotions. And maybe we'll normalize them. So what I mean by that is, let's say, we'll divide everyone's promotions by some number so that everyone's promotions is a value from 0 to 1. Now, there's some that are actually quite a bit more complicated, like pay range penetration. Well, what does that mean? Well, what that means is, for a given role, how much you're getting paid, relative to how much you could be getting paid. So it's really a percentile. How do you figure that out? Well, first you have to figure out what are all the people that work in the same role. Now, this is a hard problem because even within a company, oftentimes there are lots of different titles that basically mean the same thing. So you have to then normalize for that and group all of those people. So when Ade was talking about our Simon technology, that solves part of that problem. Then you have to go and compute distribution of people's pay for that role. And then finally, for every single worker, you have to figure out, where do they land in this distribution? So what this amounts to is every single feature is its own mini and sometimes very large analytics problem. So hence, when I say this is where the bulk of the work is, this is really a big engineering challenge for some of these features just to make them work, or a big analytical challenge to understand what's important and what isn't. So let's go back. So we've got feature extraction. What's next? Then we have model training. Well, what is this? This is the guts of machine learning. We take all of our historical data. We say, what is it we want to predict? In this case, we want to predict whether or not someone's going to leave. And we pass that to the model. And all that data, we pass it into the training phase. And all that data comes out with a model. And this model will then can be used to predict who will stay and who is go. You give it a new person, put in that person's history into the model, and it'll give you a probability of 0 to 1, saying how likely is this person going to leave in the next 6 months. Very important step, however, is model validation. Because with these, how do you know if the model is actually working? So let's talk about that a little bit. So this is what our data looks like. We have time series data. Barry got a $1,000 raise back in 2004, sometime in around mid 2014, late 2015. John and Ravi left. We hired some new people. Tejas changed teams. We've got all this data. It's time series, and let's say we have the last 6 quarters worth. So Q1 of 2014 all the way through Q2 of 2015. And what we want to do is segregate some of that data. Now, normally in machine learning, when it's not time series data, you just randomly pick 20% or whatever number you want to take, withhold it, train your model on the remaining 80%, and then validate that that model is actually working against that 20% that you withheld. In our case, we're doing something similar, but it's time series, so it has to be the data that we withhold is the most recent data. So let's say we withhold the 2 most recent quarters. We use the previous 4 quarters for training, and then we see, well, how well are we able to predict the 2 most recent quarters with just those first 4 quarters of training? And if it makes a really good prediction, then maybe we'll say, you know what, if we, assuming we give all the data, probably it'll predict the future quarters equally well, or hopefully not too far off. So that's model validation. Finally, there's evaluation. Evaluation is pretty straightforward. Evaluations take all of your data, pass it through this model that we've now trained and we've validated to make sure that it works, and actually compute the predictions, right? So actually look forward and say, what do the next 2 quarters hold? Who's actually going to leave? And that's relatively straightforward. And in our case, we then publish the results out of this machine learning pipeline back into Elasticsearch. So far, so good. And finally, why does this piece actually matter? Well, actually, as data is changing, as we have new transactions happening in the application, they'll go through Kafka in real time to our indexing service. Well, the indexing service actually will have access to our models, these models that we just built. So what we can actually do is say, well, if anything changes, check the model again and see, hey, is there a new retention risk score, a new whatever it is we're trying to predict score? And if there is, great. We can push that out into Elasticsearch. And in real time, or near real time, since there's a few second delay, managers, HR administrators, or depending on what the application is, will have access to the latest predictions, the latest state of their company, and really the current trending direction of their company. And this is, for a lot of businesses for whom maybe there's only a few companies that do this kind of analytics, and most companies are ill-equipped. So for those that are Workday customers, they are going to be having access to the state-of-the-art in predictions in HR and soon to be financials. So that's the architecture and kind of the technical overview. And if you guys have any questions, we're happy to field them. Yes, go ahead. If you wouldn't mind stepping to the mic over there.
So in the previous slide, you had this sequence that you went through, and you had the training and then the validation with the last 2 quarters. Mm-hmm. All right. Right, yeah.
One of these.
Yeah, there. Back one.
You're talking about the prediction.
There, the picture one.
Oh, this one.
Yeah. I think, yeah. So you trained with the first 4 quarters, mm-hmm. and then you validated with the last 2. Mm-hmm. Okay. So would it make sense to, after you validated, so now you've got the go-to model, would it make sense now to create a new model with all your data and then use that to predict the next 2 quarters?
So it's a great observation. That's actually exactly what we do. So that's, I didn't speak to it as clearly as I could have in this slide here, but we use all the quarters to train the model, and then we make the prediction. So it's really about, did we tune the model correctly? Did we pass in the right parameters? Are the features all predictive? And that's really what we're testing for with that validation phase. Go ahead.
So you showcased 2 different examples from 2 different domains. And when you do feature extraction, do you work very closely with your clients to come up with those features? Or like how long did it take for you to be kind of comfortable that the features that you have are relevant?
Great question. So yes, there's a lot of domain knowledge that needs to go into the features. As engineers, as data scientists, we don't really know what's relevant and what's important in a given domain, whether it's HR, financials, or any other aspect of business. Now we have opinions, but we're not necessarily the experts. So for the 2 consulting projects that we've done so far that ended up leading to the retention risk applications, we worked hand in hand with customers to understand what do they think is predictive and what could be useful features. Now, obviously, we use some of our own input and judgment as well, but without that domain knowledge, it wouldn't have been possible. And going forward, that's our model as well. So for all the inside applications that we're developing, we work with a number of design partners, and we actually build these prototype applications for them and make sure that it actually works with the input that they're giving. And then we go ahead and generalize and productize that work. Yes, go ahead. I don't know which of you is next.
Okay. It's a quick question. Similar lines. To what extent these models are reusable, regardless of the HRMS is based on Workday or some other solution?
The models are not reusable outside of Workday. They're very much tailored to Workday's own data model. Actually, and we go even more extreme than that, they're not even portable across customers. What we found is each of our customers is so unique, we need to build a unique model for each of them. So this whole flow that we've built, now it's a horizontally scalable, multi-tenant architecture, all those nice things. But we have a separate flow and a separate model built for every single customer. Yes, go ahead.
You kind of asked my second question, but the first question is,
Please.
Did you have enough data to train the model? Because typically the employees or the amount of data for a company is not that much when you're dealing with this kind of application. Mm-hmm. So did you have enough data to train your model accurately enough?
So that is an important concern that we're constantly wrestling with. Do we have enough data to train these models? And we don't always. Fortunately for Workday, as Ade mentioned, we work with most of the largest companies in the world. So a small customer for Workday has a few thousand employees, and a large one has hundreds of thousands. So by and large, any given customer has been around long enough, has enough, both breadth and depth of data to make these models work. But on the low end, Workday does have some customers that only have hundreds of employees. This model won't work in those cases. Go ahead, please.
Looked like the last step in your ML pipeline was ongoing evaluation of the model after it's been deployed. Mm-hmm. And so I wanted to ask about how would you handle the situation where the predictions that the model is making is affecting the outcomes that you're trying to measure the model against? Because presumably that's the point of the model, is to influence those outcomes.
That is an excellent question. One that unfortunately we don't have a good answer for. So the problem is that if you're making prediction that someone might leave, for example, and in fact, then you're even recommending interventions. If the managers then take those interventions and fewer people start leaving, then whatever was predictive, it may no longer hold because it's being fixed on the fly. How do you account for that? Well, in the consumer internet, the way this is accounted for is by introducing randomness. So when you're in the recommendation systems that you might see, Amazon shopping or even like dating sites or whatever it might be, when there's a recommendation, if they're doing a good job, some of those recommendations are entirely random. And they can use that data then to see, as a source of truth, to see, well, assuming a non-recommendation, what do people do and how do they react? Unfortunately, ethically, we can't really do that. We can't tell a manager false information that we know to be false just for the sake of having the right input data for algorithms. So this is an open problem for us. So perhaps in a future talk we'll have a solution.
So the question is that how do you look at the performance of the employee? So there's something that you can get from the manager, the rating, but also how this employee interacts via chat, for example, with the customers or email that is sent out. So do you measure that type of behavior, which is sort of implicit as opposed to explicit from the managers?
So it's a great question, but how do we know how well an employee is performing? There's so much of their job that happens in these secondary systems like email and chat or maybe face-to-face conversations. Today, we're not capturing any of that. The way we know how well an employee is performing is really a secondary effect of what do their managers think of them or how are they being compensated or promoted. So promotions over time is one metric. Someone's getting promoted rapidly, odds are they're performing very well. Also, Workday is the HR system. We have performance data right in there. So every quarter or 6 months or year, managers are required to go ahead and put in the performance data for their employees. So we have a score for everyone. So we use all of those sources of data, or one or a combination, depending on how the customers want to configure their predictions. But that's all we base it on. But even based on that, we found that it makes the effects very effective, highly predictive rather.
So 2 points. One is, do you consider firings?
No, we don't.
So you get rid of those firing data?
Yeah, so part of the, one of the things we have that I excluded, like I said, it's more complicated than I presented, is a filtering step where we exclude all kinds of data. What do we actually consider? So when we're looking at people who left, we're talking about regrettable terminations in HR speak, which is someone that left that the company would prefer to stay. And that goes so far as even if someone leaves voluntarily, but the manager wanted that person out anyway, that's not considered a regrettable loss. That's kind of bucketed with firings, and we don't consider those.
So the second question is, when you make these scoring or recommendation, do you give a reason? Because in machine learning, sometimes if it's a black box model, it's hard to say why this person is labeled as high risk of leaving, right?
Yes. So some of the models we run are black box, and it's impossible to tell from that model what's leading to the predictions. But we also run some algorithms that do show feature importance. So when we go back to what we said, these are the features that we're inputting, where we've got approaching 100 features now in retention risk. We can actually rank those for every single customer and say, here are your top 10 most important features, and here's roughly, or not even roughly, precisely, the percentage importance that feature has relative to the others. And we do present that as part of the application.
But for the individual employee that you labeled as having high risk of leaving, do you give individual reasons?
Yeah, so that's right. So we actually have two metrics. One is globally, what are the important features? And then on a per employee basis, what are the employee features? And we surface both of that, both of those pieces of information.
Then there's this trade-off of, precision versus explainability, right? So you rather go for explainability?
So I think what you're getting at is some models can can show you which features are important, therefore give you explainability. Some models are black box, but might have better precision, maybe a larger percentage of the time. We actually use both. So we could run one model and get the explainability numbers, and we could run the other model to get the predictions. So we don't necessarily run with just one model.
Hey, this is a little different because the question at the same time is the answer. Mm-hmm. So the question is basically, do you use data across companies? When I'm saying that means if you use employee data for XYZ, do you use it for ABC?
That is something we're not doing today. And it's not for technical reasons. Technically, it's doable, and it's actually be very useful because then we can get even more accurate models. Today, the nature of our customers, they're very large, very conservative. There's a lot of banks and healthcare companies in them, and they're not comfortable with their data being combined with other companies in any way. I think this is just a historical artifact, and that's changing, and I suspect that'll no longer be the case in the next year or two.
Okay, so the advantage I was thinking is if you can somehow model the company DNA, so you will know, right, if XYZ company DNA is like some number, mm-hmm. you can attach it to saying if this employee is promoted in 1 year, but still he's in the company, he's not promoted from last 1 year, but if the DNA is different number, if even is promoted since 2 years, he will still going to stay. If you can use that somewhere as a modeling of the DNA of the company.
Yeah, that's a great application. Another application would be, like I mentioned, there's some smaller customers for whom we cannot make predictions. Well, if we're able to aggregate data across lots of companies, and then we could figure out, well, this smaller company, what is their DNA? What do they like? We could then leverage this larger model to make predictions for that smaller company, even if they don't have enough historical data of their own. So yeah, there's lots of applications. We definitely want to get there.
Maybe
soon.
exactly it will solve the, give the answer to the other question which other guy was asking about not having enough data to model.
Yeah.
Okay, thank you.
Thank you.
So two-part question. One is, are you able to leverage the unstructured text data in the performance reviews? And second, employees, let's say they stay for a couple of years. I'm assuming because you have the data for which you're using for learning and predicting. Are you taking consideration of skill development? Somebody who started as a RDBMS developer now learned Hadoop is a much more flight churn risk than somebody who's just doing the same thing.
Mm-hmm. So for the first question, are we looking at some of the free text data in performance reviews and maybe other sources as well? And today, the only somewhat free text data we're looking at is job titles, skills, and education. That's something that our Simon technology is very good at understanding. That's our NLP technology. We're currently experimenting with sentiment analysis on performance reviews and survey data and a few other things. We don't have that in production yet, but hopefully soon.
Skills development.
Yeah, the skills development question, that is something we're looking at. So one of the things we're trying to do is we're trying to build supply. 1 minute. All right, so we're almost done here. We're trying to build a map of supply and demand by skill. So one of the things we're doing is we're pulling in huge volumes of public data, which is something we have a lot of experience with from our identified days. Both social profiles, professional data, job postings, and try to understand what is supply and demand of every skill in every geographic area. And then we're using that as features in the retention risk algorithm to predict, depending on what skills someone has, how does that affect their retention risk and potentially performance as well. So the answer is yes.
Thank you.
All right. Thanks everyone.